Hi class, welcome to exercise 4C, where we're going to be working with applications using angles of elevation and depression. Our examples and pre-learning for this lesson will be example 5, applying trigonometry in worded problems. And your pre-learning for that will be questions 1 and 2 in the new book, and for the old book you need to do questions 1, 2, 3 and 4. And then we have one more example, that's example 6, which will be combining trigonometry with some problem solving. And your pre-learning for this example will be question 6 in the new book and question 7 in the old book. Please remember though that the pre-learning is just the beginning. Okay, you need to do a lot more questions in the exercise or you won't be as successful as you could be. Alright, I'll see you in the introduction. I often use trees as a great example of when trigonometry will be very useful in real life. Measuring the height of this tree directly could be dangerous because the branches at the top probably won't hold your height. So if we could find a triangle, trig will be able to save the day, such as this triangle here. Now with this triangle, if we could measure the distance x and the angle theta, we could figure out the height. And that's because tan of theta is going to equal the height, which is the opposite, divided by x, which is the adjacent. In other words, the height will equal x times tan of theta. There's lots of tools you could use to measure angles, such as apps on your phone or an old-school clinometer. Here are some types of old-school clinometers. The real trick is to find the right angle triangle in your problem, and then we use SOHCAHTOA. So as we've already seen in this unit, a right angle triangle involves a vertical line, a horizontal line, and then we just need one more straight line to complete the triangle. When we have a triangle like this, we're looking up from the bottom, and this angle is called the angle of elevation. Okay, so here's our little man looking up from the bottom. Nearly always you'll make sure that the horizontal is matching what you would consider the earth. Let's pretend it's flat, okay? But when looking down, so in other words the vertical line is moving down, then in this case we would say that the angle theta is called the angle of depression. So if we were to put these two triangle concepts together, with this beautiful scene of a man standing on a cliff, looking down at his friend on a boat. So we can mark in our triangle that we'd use for trigonometry with an angle I'll call delta, but we can also recognise that the man looking back up at his friend on the cliff from the boat also has his own triangle, and we'll mark this angle in here and call it alpha. So delta is the angle of depression for the person on the cliff, and alpha is the angle of elevation for the person on the boat. But as we've already seen in the geometric reasoning, theta must be equal to alpha because they're alternating angles. But at this point we should note that we can use a standard sine, cos and tan when we know the angle of elevation and depression with another measurement. But we could also use the inverse sine, inverse cos and inverse tan to find the angle when we just know the side lengths. Anyhow, let's finish off the introduction and get on to some applications in the next section. When applying trigonometry to worded problems, it's really important that we find the right angle triangle in the words. Then it's important to draw the triangle, adding in the angles and distances that are given to you in the words. And once you've drawn that triangle, you need to decide if you're finding side lengths, i.e. using sine, cos and tan, or if you're finding angles with the side lengths, which would mean that you use the inverse functions. And finally, you resort to SOHCAHTOA. And this of course will help you decide which trigonometric function you're going to use. Anyhow, let's move on to example 5, where we have a helicopter that is hovering at 250 meters high, and its angle of elevation from the helipad being 35 degrees. And we're asked to find the horizontal distance between the helicopter and the helipad, which we can call x. Looking at this triangle, from the angle 35, x is adjacent and 250 is opposite. Therefore, we use TOA, i.e. tan of 35 is going to equal 250 over x. Then with two simple steps, we end up with x is equal to 250 divided by tan of 35. And this is definitely a calculator problem. So because we're talking meters, I'm going to break it down to 2 decimal places, which is centimeters. So the 7 makes the 3 go up to 4. So this is equal to 357.04 meters. Now, because this is a worded question, we should finish with a worded answer, i.e. the horizontal distance between the chopper and the helipad is 357.04 meters. Okay, so before you get to the chopper, you should pause the video and do questions 1 and 2 in the new book and questions 1, 2, 3 and 4 in the old book. And I'm sure you'll have no trouble with them at all. Once you finish those, we'll see you in the next section. Just as the title of this section suggests, we'll be doing some problem solving here as well. But basically, we're going to be doing the same things as we were in the previous section. The big difference being that there normally will be some other facts that you're going to need to take into consideration. So be extra careful where you draw your right angle triangles, which means that sometimes you're going to have to put together different bits of information to infer or figure out the exact measurement that you want. But without any further ado, let's move on to example 6, where we have these 2 tall buildings to look at. Please forgive my quote-unquote artistic skills. These are definitely not to scale, as you'll see when I do the question. Anyhow, these 2 vertical buildings are 57 meters apart. One is 158 meters and the other one is 237 meters high. And the problem for us is to find the angle of elevation theta from the top of the shorter building to the top of the taller one. Alright, so you can see we almost have a triangle here. We have an angle theta we're looking for. We have one side length that's 57, but this other side length is not so clear. So the first step is to figure that out, and clearly it's the difference of height between the 2 buildings. So that's 237 minus 158. So let's mark in 79 meters on the triangle. Perhaps that'll be clear if I write it on the inside. Alright, so we've now got a triangle just like this. And from the angle theta, 79 is the opposite, 57 is the adjacent. So we're going to be using TOA. In other words, tan of theta equals 79 divided by 57. So applying the inverse tan function to both sides, we now get theta is equal to inverse tan of 79 divided by 57. And of course, this is once again a calculator problem. Therefore, theta is equal to 54.1888, so on and so forth. Or I could round it up to 54.19 degrees. Okay, so that's the example for this section. I think once again you'll find this pretty straightforward. But please now pause the video and do question 6 in the new book and question 7 in the old book. And then please come back for the summary, because it is really important that you do take note of the skills that you should be taking away from this lesson. Hopefully you can see applications is where trig really comes alive. I'm sure you could now imagine many problems you've thought of in the past and think of ways to solve them with trigonometry. But as you're working through this lesson and this exercise, make sure that you do plenty of these questions. You need to practice reading carefully and finding the triangle and its measurements in the question. Then you should draw a diagram with that triangle to make things much clearer. Anyhow, in this lesson, to be successful you will know how angles of elevation and depression are measured. Be able to draw and label an appropriate diagram from a worded problem description, and then identify a right angle triangle. And finally, know how to apply the correct trigonometric relationship to solve this problem. Okay, so make sure you note down those skills and check off that you have got them all. Otherwise, we'll see you in the next lesson or next video. Bye.